This is another example of a linear equation in one variable. Equation, only one variable, x, and the exponent on the variable is 1. I do have an added twist to this problem in that I have fractions, but the variable does not appear in the denominator of the fraction. That's what keeps it a linear equation in one variable. If the variable appears in the denominator of the equation, we're not really sure what kind of equation we have until we remove those fractions. And that's actually where we want to start here. In fact, here's a general rule of thumb. Whether you have equations, inequalities, if the equation or inequality contains fractions, perform an operation early to remove those fractions. In general, it just makes the problem easier if you no longer have to deal with fractions. And the technique we use to remove fractions from an equation or an inequality is to find a multiplier that if we multiplied both sides of the equation by that quantity, it would cancel out the denominators. Now, if I multiplied both sides of this equation by 4, it would cancel the denominators here. Let me illustrate that for you. Remember, we have to do the same thing to both sides of the equation. Now, look what happens when I multiply this fraction by 4. Remember, that's like multiplying by 4 over 1. And aren't you going to be able to do some canceling there? The 2 will go into the 4 2 times, leaving us 2 to be multiplied by x. Here on the right-hand side, I'll have to use my distributive property. I'll have to multiply the 4 times both of those terms. And now again, when I multiply here, won't those 4's cancel, simply leaving me 3x plus 4 times 5 is 20? And I have completely removed the fractions from that equation, producing a much simpler equation to solve, which still is a linear equation in one variable. And now, well, there's no parentheses left. These expressions can't be simplified, but I have the variable on both sides, and I don't want that. I want the variable in just one term. So I'm going to subtract 3x from both sides so as to remove the variable term from the right side. And now all I need to do to finish out the problem is to get a coefficient of positive 1. So I divided by the coefficient that was already there, negative 1. Dividing both sides by negative 1, our solution is that x equals negative 20. If we put negative 20 in place of x in the original equation, the value of the left-hand expression will be the same as the value of the right-hand expression. Here was a little added twist. We had fractions. What did we do first then? We removed the fractions by finding a multiplier that when we multiplied through canceled all the fractions that were there. We're going to see that in several other problems here just in a moment.